Welcome to solverfy.
Here we have a circuit consisting of two parallel branches with a potential difference V, which is equal to 120 volts, and this is applied across each of the branch. And one branch is the rotor represented by RF, the resistance, and an induced EMF that opposes the applied potential. And so we, for part A, the field coils and the rotor are in parallel to the applied potential difference. So the potential difference from over here, let's call it A, and this point to be B. So the potential difference across AB is gonna be I times R, and that is equal to IF times RF. And from here we can find the current, which is equal to V over RF, and we get this value to be 1.13 ampere. For part B, we apply the junction rule to point A in here, and it gives I minus IF minus IR equals to 0. So this current I over here is basically splitting into two branches, two components we can say. So that's IR and IF. And from here we can find IR, which is equal to I minus IF. And we know the value of the total current. And we found IF over here in part A. So we are going to use those values and we get IR to be 3.69 ampere. So for part C, we know that the potential drop across the rotor is IR, I times R plus the induced voltage, and this must be equal to the applied potential difference V. So V is equal to IR times RR plus epsilon, and using this equation we can find the induced EMF developed by the motor. This is equal to V minus IR, and this gives the induced EMF to be 98.2 volt. And this should be as directed so that it opposes the current through the rotor. Now for part D, we know that the mechanical power output is the electrical power output minus the rate of dissipation of electrical energy in the resistance of the motor. So electrical power output to the motor, which is the input power, is equal to I times V, and this gives the input power to be equal to 578 watt, and the electrical power loss in the two resistance, let's call it P loss, this is equal to summation over I square R, and the summation is over all the branches or all resistances. So this is equal to IF square RF plus IR square RR, and this gives the power loss to be 216 watt. So the mechanical power output will be equal to power input minus power loss, and this is going to be equal to 362 watt. The mechanical power output is the power associated with the induced EMF E that we found over here. So PE or P out is equal to epsilon times R, going with this equation over here, I times the potential difference, and this is found to be equal to 362 watt, which agrees with the above calculation over here.